If you've ever been daunted by an experiment that will seem to take forever, you might need an iterative simulation. Just type in variables, run the results, and examine data that may have taken a few months to a lifetime to get. Anything from genetic mutations to public health, the spread of germs, COVID, CDC, glacial ice melting, motors or tires wearing down, consumer responses to or demand, and in relation to pricing. These are iterative simulations. And my task today was to design an iterative simulation that would be interesting to my students, and the one I chose was what they do in the bathroom. Actually, it's playing craps. They take a towel, they lay it on the floor during lunch, and they play. So one day I heard one of them say that they have a way of throwing that can guarantee them a win. And I thought, 6 sides of dice, exactly, unless you pick it up and twist it and cheat in your throw, you may not actually have a way that guarantees your win. And then let me explain. Iterative simulations can explain that. Now, what I did first is I did 25 rolls, 4 different ways. From my left hand through the top of my hand, from my left hand through the bottom of my hand, from my right hand through the top of my hand, and from right hand through the bottom of my hand. And I added together the dice, each die, and found the total. And in the end, I also found, this is sheet 2. We don't want to go to sheet 2 yet. And in the end, I also found the mean and the standard deviation of each die and the total. So what I was going to do was take that standard deviation and run a random number between 1 through 6 with that standard deviation. You can kind of do that with the norm items. So this would be the random number, this would be the place where I put the mean, and this would be the place where I put the standard deviation. Now sometimes I'll get a number for that, but sometimes I won't, and I haven't figured out why. Even when I click on this, because it's random, it's volatile. So if I click on it, if I click on it, I'm going to click up here, it will change, and all of my numbers on the screen will change. So I had to figure out what else I wanted to do because my formula just was not working. So I'm not quite there yet for being an expert in this. However, I thought, well, what about how many times a number will show up per type of throw? So obviously with these 25 that turned into 50 dice rolls, I did the frequency of each. Now the formula for that is count if, and then your column, and then the number 2. And the same for the number 3, the same for then that column and the number 6, okay? And then I did a table from this, and I clicked on Insert, and I clicked on the line graph. Obviously, I did not put a chart title in there yet. And I did a visual image of what that would actually look like. Now, this is not an iterative simulation. Why? Because it's not really a simulation, and it doesn't really go on forever. I did this, I kind of got bored after 50 times 4 rolls of 2 dice. But an iterative simulation is a simulation. It will change. This will change the whole thing. Notice everything changed. So it will change, and it possibly goes on forever. This goes on for 1,000. There is no way that I would sit here and do 4,000 rolls of dice just to get these numbers. It's kind of like a Rube Goldberg kind of thing, and it's a lot of work for a little bit of data that doesn't really mean much to me. But the kids would look at it, and I think they would find some of this interesting. Now, again, that's 4,000 rolls of dice, and here we have the results for 2 through 12. What will you get? Notice that these are not even. And why would they not be even? Because there are only two ways to get 2, or one way to get 2. It's 1 plus 1, right? I should have said 1 plus 1. There's only, one way to get 3, 1 plus 3. There are a couple of ways to get 4, right? So the more ways that there are to get a certain number, the more results you're going to be able to get when you roll dice. And that's why the numbers 6 and 7, all these numbers in the middle here, are going to be your more frequent numbers. And that has a lot to do with whether you're going to put money on pass or put money where they don't get it. Okay? So thanks a lot. I hope this explained a little bit more about what an iterative simulation is.